Hello, hello, beautiful people, and welcome to some word problems using exponential growth and decay models, as well as some other stuff that we'll do in 7.2. But for now, let's talk about this. Exponential growth and decay used when a real life quantity increases, grows, or decreases, decays, by a fixed percent each year, so over some period of time. We will be using this formula. I would love for you to focus on this and try really hard to memorize it. And what means what. So y is the amount after however many years. T is going to be your time, so the number of years. A is the initial amount. R is the rate of growth or decay. So if it's growing, you're going to add the R. Kind of makes sense. If it's decaying, you're going to decrease the R. 1 plus R is going to be your growth or decay factor, depending on if you're adding or subtracting on that part. Sounds good. This is a formula. It's pretty straightforward. So let's go ahead and try an example together. You will need your graphing calculator. So if you don't have it, go ahead and grab that really quickly because you'll need it for these problems. I do not expect you to do these numbers in your head or by hand. Currently, there are 40,000 homes in a city. 40,000 homes. Delightful. What does that sound like to me when I'm looking at those variables? It sounds to me like that is my initial amount. Each year, 10% of the homes. So let's go for this 10%. That sounds like an R. However, one reminder, whenever you have a rate, you're going to move the decimal point over twice. So it's going to be 0.1 for that. What else? Oh, homes are expected to connect to city gas. Okay, so every year 10% of the homes connect to city gas. Great. Write an equation to model the number of homes, so that's going to be my Y, that do not have city gas. So each year that is increasing. The number of homes that do have it does increase every year, but the number, so as more and more people have it, less and less people don't. So let's think about that. Is that growth or decay? That's going to be a decay because the number of people that don't have it is going to decrease as more and more people connect to city gas. So my A is 40,000. And then 1 do not have it. So minus 0.1 to the T. I don't know. They didn't tell me how much time, but they only asked me to write a model. I will, however, simplify 0.9 to the T. Would this be exponential growth or decay? Decay, because this decay factor, this factor here, is less than 1. Okay, the next thing for part B, use this model to now estimate how many homes do not have city gas after 5 years. So I'm going to go ahead and then plug in my 5 for my time. And then I will have you use your calculator for this part. And if you're not sure how to use your calculator for these numbers, you can go ahead and check in with your teacher. But you'll just use the caret button, the arrow pointing up. So you can just do 40,000 parentheses 0.9 parentheses and then raise that caret button, which is right above division to the 5th power. And then when you punch that in, you can simplify that and get that it is about 23,620. So after 5 years, 23,620 homes will not be using city gas. Now, you should write sentence answers. I'm probably just going to read them off just to save a little bit of time and trust that you can write sentence answers for these. Step 2 for this one, part C, is to graph on my graphing calculator and determine approximately when 17,200 homes will not be connected to city gas. So I remember how to do this from previous lessons that we've done, and so I'm going to make the first equation for Y1 will be equal to my decay model times 0.9. When I enter it in, instead of an X, instead of a T, I'm going to use an X. And then Y2 is going to be 17,200. Now, the thing is, let's think about a reasonable window. They didn't really give me any stipulations for time. So I'm going to go ahead and give myself a nice buffer of -1. If you go too negative, it's like you're back to the future and you're going to go back in time 5, 10, 15, 20 years. So -1 is good. And then let's go out to, I don't know, 20, 30 years. I'm going to go for 20 years. And I'll go by 1s. Probably I could go by 2s as well. That's reasonable as well. Now I really only care what's happening at 17,200. So for my range, or from my Y minimum, I'm going to go 17,100, and then my Y maximum is going to be 17,000 sorry, 300, because it's right in between there. If you did 17,150 and 17,250, I'd be fine with that. I'll probably go by 30s for that. And then I want you to graph it, and after you graph it, I would like for you to, as you recall, hit Calc Intersection. Calc Intersection. Okay, so this was my graph. It looks like it's 2 lines, but it's not. It's just because of the way that we graphed in. And again, you're going to do second calc. So this is second calc. Ooh, there you go. Second calc. Intersection number 5. And then you just hit enter, enter, enter. And your intersection is at 8.01. So it's 8.01, comma 17,200. So what year would this be? Well, if you started out, oh, I didn't ask you what year it was. So it's just after 8 years. So after 8 years, 17,200 homes will still not be connected to city gas after 8 years. Okay, the next one, that was fun for the whole family. You purchase a stereo system for $830. After 3 months, the value of the stereo system decreases, that's a hint there, 13% each year. Perfect. I would like for you to do 2 things. Number 1, write an exponential decay model for this and situation, and then part B, find the value of the system after 1 year. When it says solve algebraically, it just means plug in 1 for the value of year. Do that, please. Go ahead and press pause and then check your answers with me. Perfect. Go ahead and check your work with my work. This was a decay model, so I subtracted the 0.13 and got 0.87 to the T. And then when I plugged in 1, I got $722.10. Good job. Okay, for our next example, in 2000, the tuition for a private college was $20,000. During the next 11 years, the tuition increased by about 7.2% each year. Write a model given the cost C of the tuition in college for T years. T is the number of years after 2000. What else is important? This right here looks like what? It looks like an initial amount. So I'm going to label that A. And then it is increasing by 7.2. So that means my R is 0.072. And this increased by is just telling me that it's going to be going up. So if you could please, let's write down what you think your equation should be. Oh, the cost C this time is not a Y. So C equals 20,000 to begin with, and then 1 plus the increasing rate, which is 0.072, all raised to the T power. So my model is 20,000 times 1.072 to the T. Next part, you can plug in 10 for T to find the tuition after 10 years. And then you can use your calculator, of course, for this type of problem. And you can trust me to push my buttons in correctly, I guess, or you can check me. I would appreciate that too. So what's my sentence? The tuition in 2010 would be about $40,084.63 approximately, and according to the model. Now, part 2 of this is to graph the model on our calculator, and let's write down the model. Let's write down the window that we used. So this is just the same as a repeat, so that we had it on the same slide without having to go back and forth. my model would be y equals 20,000 times 1.072 to the x when I put in the calculator. And then for your window, I'm going to give myself a little bit of a buffer and not start right at 0. And then I will go out to, I'm going to say probably about 20 years again, and I'll see if I have enough information to answer the questions. Typically, I would probably stop like right about 11 years or so because it says it was calculated for the next 11 years, but I'm using this model to predict for the future. So I'm going to go out to at least 20 years. If you said 30, maybe even 50, but I wouldn't push it too far past 50 years for this. A minimum would probably be what? Well, it's starting at 20,000, and then what's happening is that it's going up over time. So I probably would go 20,000. And then I looked at my last problem because we went for 10 years. This is going for 20 years. It's going to keep growing up. So I know that at 10 years it was 40,000. So I feel like maybe I'll just go up to like 60,000 and see if I see enough information. So my Y max is 60,000, and then my scale, I'll probably just go by 3,000s on that. Okay, so then I'm going to have you, it says graph to find the tuition in 2005. So for that, I'm going to use my calculator, but first thing I want you to do is go ahead and enter all of this in and then hit graph, please. And let's see if our graphs match up. All right, so this is my graph, and then I want to find a specific value. So I'm going to go back to the second trace like we did before for calc. So second trace, and I want a value this time. So I'm going to hit number 1, and I want to find out when X, or the year, is 2005. I'm not going to enter 2005 because this is just the number of years since 2000. So I'm going to hit 5 because there's 5 years after 2000. And then I'll hit enter, and they are telling me that gorgeous number. It's maybe too small for you to see. So I'm going to say X was equal to 5 as a note here. And when I punch that in, I got Y is equal to 28314.76. Oh, just kidding, 0.176. I missed the 1. So that's going to be about $28,314.18. According to the model, it should be about that much money. Okay, so the next thing is kind of the opposite. I'm going to make Y2 equal to 50,000. And I would like for you to calc intersection as we did in the last problem. And go ahead and press pause and do that. And then if you did, you will get in 2013, the tuition would be about $50,000. All right, sounds fun for everyone. Okay, do me a favor. I would love for you right now. It's kind of like a Dora the Explorer type of moment where I want you to try something on your own. And so I would like for you to try now, please, this next problem, except I'm going to help you out with A a little bit, and then I want you to continue on for the rest of it. So we have the number of newly reported cases of tuberculosis in thousands. That's important to know. In the United States from this year to this year can be approximated by the equation T equals this. They're giving it to me, where T represents the number of years since 2000. Identify the initial amount, so that's the A, and that would be 28.5. The decay factor is going to be the 1 minus 0.9567, and that would mean what? That the percentage would be whatever this difference is. So if I subtract that using my calculator, or just doing it in my head, I think it's 0.0433. You can check me in the calculator. But the actual percent when I move that over is 4.33%. Okay, this is the factor because it's always whatever this is. And then this will be your percentage when you actually subtract that. Okay, from here, I would like for you to graph this on your calculator. Go ahead, press pause on this video, graph it on your calculator, and then answer the questions for B, C, and D. Perfect. Okay, so I used this window. Made sense to me. At the time, I used the same thing. Don't forget, we're talking about thousands here, though, so I went out to 30 because it's decreasing, so I didn't go very much past that. you want to stay around 30, maybe 35 at most, but don't go too much higher than that. And then from there, the graph is going down, so you don't need to see much extra. For part C, I made Y2 25, not 25,000. I made Y2 25 because my formula is in thousands. That's kind of important. It's tripped some of us up before in the past. And when I calculated the intersection and did not use trace, I got 2.96. So in 2002, there would have been approximately 25,000 cases. And then for part D, you can do the same thing that we did for the other one, where we did calc value, and get that it would be 14,672, or you can just plug in 15 for T and simplify that. I do prefer this for myself personally because I don't really feel like I need the calc value part so much. All right, that is that lesson, and thank you so much for joining me.